Welcome to Dataless U. I'm Paul, coming to you from Brooklyn. Today we are going to take a look at a concept in calculus called integration by parts. We're going to do a problem from our favorite calculus textbook, old James Stewart's Single Variable Calculus, Concepts and Context, version 3. So open up to page 398 and take a look at number 13. I've already got the question up on the big board, and it is, what is the integral of e to the 2x times sine of 3x dx? Now, at first glance, we don't know the integral of such a function with an e in there and a sine in there. Of course, we could take the integral of one of them independently, but not the two of them together. In order to do so, we have to use a method called integration by parts. Integration by parts method is derived from the product rule of taking derivatives. We're not going to really go into that in this video, but just so you know, that is where it comes from. And although it looks a little odd, it does make a lot of sense. So the formula is the integral of v dv equals u times v minus the integral of v du. So what are all of these u's and v's? Well, we are going to assign certain parts of our function to v and dv. Okay? So our v, well, let's start with the u. Our u is e to the 2x. Generally, if you have an e, you're going to want to assign the e to the u, because it's an easy function to take the derivative of. Now our dv, so notice we're assigning u and dv. Our dv is what's left over. That's sine of 3x times dx. So there we have it. To do integration by parts, you have to assign the u and the dv. Then the next step, we want a dx here, of course. Then the next step is to take the derivative of the u. Well, the derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. So we have 2e to the 2x. Simple chain rule. One of the reasons we assign the e to the 2x to the u is it's an easy function to take the derivative of. The derivative of e to the u is just e to the u, du. Now we're going to take the antiderivative of our dv. The antiderivative of sine of 3x dx requires a little u substitution. We'll say that 3x is u, so we need 3 du. And in order to put the 3 in, to take our integral, we're going to have to take a 1/3 out. So here comes our 1/3 times, of course, the antiderivative of sine x is negative cosine x. So v in this case is negative 1/3 times the cosine of 3x. And there we have it. Now we just look to the right, look back to our formula, and we plug in our values. So our original function, our original question, what is the integral of e to the 2x times the sine of 3x dx, equals, first, u times v. Well, u is e to the 2x. So we'll write that first. And v is negative 1/3 cosine 3x. Minus the integral, another integral, of v du. Well, v is again then negative 1/3 cosine 3x. Now, we're going to take the negative 1/3 out. So I'll go ahead and make this minus sign a plus sign, because we're taking the negative 1/3 out. And I'm going to squeeze my 1/3 right here in front of the integral. And then I'll write cosine 3x times du, which is 2 times e to the 2x. So we're going to go ahead and bring that 2 out as well. E to the 2x we'll put in here, and we'll erase this 1 and put the 2 in the numerator. So the integral of our original function is e to the 2x times negative 1/3 cosine 3x plus 2/3 times the integral of cosine of 3x e to the 2x. Well, look what we have. We have another integral that is going to require, you guessed it, integration by parts. So this is one of those classic questions in calculus that gives many a student an enormous headache because after the great success of doing integration by parts in step 1, we are forced to do it yet again. So let's go ahead and assign our u. Our u is going to be e to the 2x, just like it was last time. And our dv this time is going to be, oh, I forgot our dx. Let's get that dx in there. Our dv is going to be the cosine of 3x dx. You need the dx, you need the infinitesimal in order to take the antiderivative. So next we take the derivative of the u. So du, just like last time, is 2 times e to the 2x. And then we take the antiderivative of our dv. So v is, just like last time, we have to put in a 3 to take the antiderivative, so we'll get a 1/3 outside of the integral. So our v is 1/3 sine of 3x. Okay, we're coming along. So let's see what this equates to when we plug it into the formula. First, we're going to rewrite the first term, and we'll tidy it up a little bit. We'll say negative e to the 2x times cosine of 3x all over 3 plus, now my recommendation to you is to be careful with your coefficients when doing integration by parts. In many ways, keeping track of your coefficients, our coefficient in this case is our 2/3, you know, that little fraction that's out front of this whole integration. 2/3 times what we get when we plug our u's and v's and dv's into our integration by parts formula. So let's put a big bracket here so we can keep clear that our 2/3 is out front of all of this. So first, u times v is simple enough. The u, I guess we don't need this parenthesis, we'll just put the u right in there. The u is e to the 2x. The v is 1/3 sine of 3x. Go ahead and put that in parentheses. Make sure we see the product of these two. That's u times v. And this is minus the integral of v du. So v is that 1/3 sine of 3x. Again, we're going to take the 1/3 out. We'll squeeze it here in front of our integral. Always a good idea. Keep your constants out front of the integral. So the v is the sine of 3x with our 1/3 out front times du. Du again is that 2 times e to the 2x. So we'll take the 2 out. We'll just turn this 1 into a 2. And we'll put our e to the 2x inside the integral. Now, don't panic, but look what's happened. The integral to which we have arrived is the same integral with which we begun. It's the integral of the sine of 3x times e to the 2x. Well, that's where we started. That seems a little frustrating, doesn't it? So at this point we have two options. We could do integration by parts ad infinitum until the cows come home, so to speak, and it would go on forever and ever. Or we can use a nifty little algebraic move and be done with this integral in moments. So let me show you what I mean. We have e to the 2x times cosine 3x over 3. And with integration by parts, I recommend you just rewrite everything, be meticulous, because every little detail counts. Plus, and here, we'll go ahead and multiply this 2/3 through. So we have e to the 2x times 2 times the sine of 3x all over. In the denominator, we have 3 times 3, which is 9. Minus, well, we have a 2/3 times a 2/3, which is a 4/9. Again, keep very close track of these constants. So we have 4/9 of this integral, which is the integral of the sine of 3x times e to the 2x, which, to reiterate, is the same integral with which we started. So keep in mind that this is an equation. We have the integral on the left-hand side, even though it's written all the way at the top of the page, which is equivalent to these three terms that we have now at the bottom of the page. So the nifty little trick is to simply add the 4/9 of this integral, currently residing on the right-hand side of the equation, over to the left-hand side. Does that make sense? We are simply going to add 4/9 of this integral to the left-hand side of the equation, where we have one of them. In other words, we have 9/9 of the integral over there. So when we add 9/9 and 4/9, we get 13/9. I'm going to write the whole thing out now. That's 13/9, the integral of e to the 2x times the sine of 3x times dx, our infinitesimal. And just now I noticed I left out an infinitesimal up here. Let's just throw that in there. And also right here, don't forget your dx's when taking your derivatives. And this is equivalent to these two terms that we already have. Now I'm going to go ahead and put them in brackets, because what we're going to do is end up multiplying through by 9/13. So write everything out. We have negative e to the 2x times cosine 3x over 3 plus 2e to the 2x times the sine of 3x over 9. So, in order to solve for the integral of e to the 2x sine of 3x dx, all we have to do is multiply by the reciprocal of 13/9, so that we can get just that original integral on the left-hand side and our answer on the right-hand side. So it's a pretty simple trick. We're going to multiply both sides by 9/13. Just a touch of algebra. So notice here, we're multiplying both sides by a funky fraction, 9/13, hence my insistence along the way of keeping very careful track of all of the constants and coefficients and so forth. So let's write out our final answer. The integral of e to the 2x times sine of 3x dx equals, what happens when we multiply 9/13 through to these two terms? Well, 9/3 becomes just 3. So we have a 3 in the numerator. Let's say right here, negative, because there was already a negative there, times the 3 times e to the 2x times cosine 3x, and that's going to be over the 13, which is going to be multiplied through or distributed, which will now be our denominator. And that's going to be plus, here the 9's cancel, so we're left with just the 2 in the numerator times e to the 2x times sine of 3x. And this fraction 2 will be all over 13. This essentially is our final answer, but teachers and textbooks like to make things a little prettier. So we'll take one more moment and write it as follows. Why don't we take out the 1 over 13? They both share 1 over 13. They also both share e to the 2x. So we'll take that out. And then we'll just reverse them and write 2 is left, 2 times e, or 2 times sine of 3x, because we've taken the e out, 2 times sine of 3x, minus 3 times the cosine of 3x, and that's it. Plus c. Don't forget your plus c. And that's the answer. We are done. The integral of e to the 2x sine of 3x times dx equals 1/13 times e to the 2x times quantity 2 sine of 3x minus 3 cosine of 3x, all plus c. That is integration by parts with the nifty little adding over of the integral of the original integral. And we are done. I hope you've enjoyed this, and I will see you in the future.